All right, so
Thanks,
if
Greg.
there are any questions for any of the presenters in this session.
I had a question for Lisa if she's on.
Yes, I'm here.
Hi, Lisa. In your probabilistic um, measuring of earthquakes and their effect on structures, where you honed in on faults that have been mapped on the moon, is there any way to incorporate impacts either from some kind of stochastic modeling or from what we've measured from the Apollo seismic data?
Yeah, that's a great question. Something we've been thinking about that uh, in addition to earthquakes, you could have ground shaking from impacts, and that, on Earth, we don't worry about that as much because of the risk levels lower, but on the moon, it's so much higher. The amount of impacts would matter potentially. So we would probably add that. There are records of meteorite impacts, so we could make a similar catalog, magnitude occurrence relationship, and that would be another potential piece of the hazard that I think you're right would be really important to consider for.
Or is it easier to, once you know where your habitat's going to be, just model different size impacts at different radii from that? Is that easier and a better way to do it?
That's a good question, actually, because you would want to look like the idea being like specific regions. So I guess meteorites could happen at random locations, and who knows where they go in the future. But I guess you'd want to use what data we have, but if that dominates the hazard, it turns out that meteorite impact ground shaking is much more likely than earthquakes. It's a hazard. It could be a way to zone in on it as well. Yeah, it just would depend, I guess, on how the statistics worked out. So that's definitely something to think about. Thanks.
There is a point made by Tom Gajira in the chat about LROC potentially providing impact source locations too.
Oh, interesting. Yeah, you could, I guess, use the craters themselves rather than just the quake or the impacts we've measured. Using the actual fresh craters as a proxy, that's a great idea.
I have a question for Alex Parker if he's still on.
Yep.
I was wondering if your moats were designed to withstand the lunar night, and if not, are there plans to design for the lunar night?
I'd say they're not, and right now that's not something that I'm pushing toward. There's so much that can be done. Basically, we're really pushing the envelope down into these sub 50-gram payloads, and it's really everything I've looked at to make persistence into the lunar night. We could probably persist for hours, maybe tens of hours into the lunar night. Once once the sunlight has shut down, but maintaining enough onboard energy storage to maintain temperature through the lunar night is a challenge beyond the one that we're looking to solve right now. Now, it may be possible to do, but it's not something that we've got on the table at the moment. We're intending these to be sort of short-lived arrays built around an individual mission where activities are ongoing.
Gotcha.
And I had a question for Eldar if he's on.
Hi, Eric. I'm on. Can you hear me?
Yep, we can hear you now. Great.
Okay.
So I had a question about how when you're doing remote mapping and you're refining your hypothesis maps,
Yeah, sorry.
how
Yeah.
quickly can that happen? You know, if you have 5 hypothesis maps, or can you have 100? And if you're updating, is it fairly instant, or is it something that takes hours or days? You're muted, Eldar.
Can you repeat the question, please? The whole thing just kind of crashed for a second there.
Sure. So you were saying in your talk in abstract that when you're having a rover going out and collecting data based on the hypothesis maps, you can actually go in and revise them with new data. How long does it take to do any kind of revision, and how does that work if you have 5 maps versus 100 maps that you're trying to revise? Does it take hours or minutes to make the revisions?
So there's 2 types of revision. So the short answer is that the rover does the revisions on the fly, right? What the rover is trying to do is it's trying to reduce the uncertainty in a what do you call it, in the hypothesis map, where basically if there's multiple geologic units for 1 pixel, that is greater uncertainty, so it goes there to reduce the uncertainty. So when it gets there and it performs the measurements, it already starts on the fly reducing the uncertainty for that specific. If it discovers something new that it does not understand, because there's no hypothesis associated to it, some mineral that it doesn't know how to look up, for example, in this case, then it contacts the scientist, and then the scientists need to look at the data, and they need to recreate to create a new entry for that hypothesis map, perhaps a new plane, a new geologic origin plane, or something that allows them to feed back the updated hypothesis map to the rover. And that in turn depends how long it takes the scientists to figure out what they need to do, what kind of update they need to do to their hypothesis. But insofar as the rover performing the discovery process of going to different pixels, so to speak, to query them, those updates are done on the fly.
Okay. Could your hypothesis maps be used with biosystems where it would monitor hypothesis maps that are tied to an astronaut's, biology, looking at heart rate, oxygen level, solar storms, or anything like that, that could inform astronauts on when they need to get back to habitats or do certain tasks?
Hello? Sorry, this all froze. Oh gosh.
we can hear you.
Let me get closer to my Wi-Fi here. This is ridiculous. Okay, go again. Something associated to the astronauts bio.
Yeah, could you use hypothesis maps to, in a biological realm, to inform astronauts, when they should do certain tasks based on, their heart rate or oxygen levels, or a solar storm? It could help them, perform tasks in an efficient way.
Well, that's not what we designed the hypothesis map to do. It's more of a querying tool to actually address scientific hypotheses, to allow a rover to actually address scientific hypotheses. So it's not necessarily. I'm not sure that how you would do that. How you do that. in this case.
Okay, thanks.
I have a question for Alex. He's still there.
Go ahead.
Hi. My question was, I don't know if I missed that in your talk, but how does this scale up with the number of nodes in the network? Like as the number of nodes go from hundreds to like 200 to 1,000 or something, what's the kind of maximum delay to reach from one node to another node, or for the mesh to converge to a fully connected status?
That's a good question. We've been, building our own understanding of it and looking for examples of really large networks, because there's a difference between, theoretical capacity of how many addresses are available on a given network versus the actual performance and latency between nodes. And one of the key optimization parameters when the node is redefining itself as the maximum number of hops allowable in a network between any two nodes. So if you're in the network will drop packets if a packet has routed through more nodes than that limit, and that's there to prevent basically packets from walking around the network perpetually trying to get to an end station that is no longer there. So the way we're using sort of a standard number for a smallish network of maximum of 7 hops, and you can work out your maximum range given an individual point-to-point connect between any two nodes, and the 7 nodes if you're only going basically linearly through the network. When we've talked about building larger networks, getting toward tens, it scales reasonably well up through tens of nodes, and there's plenty of examples of people using networks in that sort of scale. When you want to get to high data rates and low latency with very large networks, we have to start moving away from the commercial mesh network standards just because they aren't designed for that, but we can build off of those frameworks. And so building, what we're looking at building next is a 2-layer network where a low-layer network has the role of basically coordinating communication between nodes, and then a higher layer network acts as an optimized serial channel between any two nodes that are trying to communicate with low latency. And so you essentially assign roles in that low-level network, 2 nodes to act as either relays or data sources or endpoints, and then that upper-level network communicates the data quickly from point to point, and then you can balance traffic across them. And all the modems that we're using, all the transceivers are capable of multi-channel communication on board, not simultaneously, but they can certainly swap between networks. So there's a couple different architectures we're looking at for pushing into this hundreds or thousands of nodes space, and there's fewer obvious examples of them functioning in the kind of conditions that we're interested in doing it. So we're going to have to push into some new territory here. So stay tuned.
Okay, so just a follow-up question on this. So in the new frame, in the current framework, so I'm guessing there will be packet loss, and in the new framework, you will be working for avoiding packet loss.
There's, in the existing standards, there's systems for monitoring packet loss, and if you can flood the network and you can start losing packets. I have a relatively crude method that's implemented on the existing network. It's basically exchanging checksums and looking at whether or not all of the data in a given ring buffer on board a given sensor node has actually made it back or not. And if not, then we step back to the ring buffer and send the missing parts. And there's way smarter ways to do it, but there's also very simple ways to build resilience in the network to packet loss or whole payload loss. So yeah, there's definitely solutions to that, ways to managing it.
Thank you.
I have a question. I was interested, Brian mentioned incorporating the seismic hazard maps into his tool, and Alex mentioned the MIMS measurements could be useful in PSHAs. Just kind of curious about anyone's ideas for kind of collaborating or how to kind of link, if you guys have ideas on that, of what we could do to make the data more usable.
Nick and I were having a conversation in the chat about some possibilities related to the work that you presented. Things like, these synthetic waveforms that you're generating, those would be super valuable for me to build, optimized detection systems and determining the amount of, processing that I want to be able to do on board to smartly, do data decimation and actually threshold on the data that we're receiving instead of sending back the whole stream to be dealt with later. So, I would certainly like to work with the other teams here to exchange information about, those synthetic waveforms would be super useful for me. I'd be happy to deploy any prototypes that we have in any given field site that someone else wants to go to try looking at operational, concepts of operation or, yeah, anyway, I'm game.
All right, awesome. That sounds really great.
Yeah, we're starting to have some preliminary conversations about how we can integrate the rockfall analysis with your probabilistic analysis and take a look at what the potential collaborations could be. I think there's a lot of opportunity there.
Yeah, that sounds ideal to have rockfall combined with seismic hazard, and what do all the hazards mean together, and how do they show up on the map, or when you combine the hazards. It'd be interesting to see how it might vary at different locations we're interested in.
One thing that occurs to me would be just in terms of thinking about predictions that you could make or directly from your work that would be potentially valuable for guiding instrumentation going forward would be things like, for a given landing site, what's the minimum or, where does the cost of a new measurement versus its value inflect at getting you a refined estimate of the seismic hazard at that site? So, you were talking about how knowledge of the subsurface at that area is going to influence all of the predictions about seismic hazard. And you can make some educated, I don't want to say educated guesses, but you can make some inference about what the subsurface is like from what we know from Apollo. But if you wanted to deploy, the minimum viable network of new sensor nodes at a given landing site to update the hazards at that site to make really, clean hazard predictions, what would that network look like? And is there a way that from the work that you're doing, you could actually start to define what measurements would need to be made at any given site to do that update?
Yeah, we're hoping, putting in what we have could start to highlight like the gap and how we could have a map to say where do we need to go to improve the hazard. I mean, on Earth, there are requirements to get measurements for critical facilities, like at a borehole, right over where you're going to put a facility. But given that we aren't at the moon and might have to decide or strategize, I think that's a really great idea. And people do that on Earth to think about, siting, where do they want to put facilities, like where we'll do some preliminary regional maps using remote sensing or even before going to the field. So I think that's possible. Definitely worth thinking about.
So, so I'm going to suggest, it seems like things are slowing down just a little bit, and we have a IT team that got up very early and desperately needs a break. So I'm going to suggest that that unless there's any last questions, that maybe we call it a day at this point. Jeff, do you good with that? And Nick, everyone?
I'll second
I'm
the
good with that.
motion.
Great. Thanks so much, everyone.
Yeah, thanks to the staff for putting this together, the IT staff, and all the speakers in this session. It was a great session. Thanks.
Sure was. Yeah, thank you. Bye-bye.
Bye.
Thanks so much, everyone.